First question that comes to mind, of course, is what is moisture? We're going to get into that to some detail and why it's important to measure it. Of course, the Earth is covered with moisture, about 70% of the Earth's surface. There is water vapor pressure throughout the atmosphere, and because of that, it affects most industrial processes. So it's important to understand what water vapor is, why it's important to measure, and how is it measured. So throughout the presentation, we're going to be talking a lot about dew point and frost point, relative humidity, as well as parts per million by volume, or on a volume basis as opposed to a weight basis. The ensuing slides will dive into that into some more detail. So why measure moisture or water vapor? Well, because it is so prevalent in our environment, it permeates most processes and materials. So in the manufacturing process, moisture can have a very big impact, and usually a negative impact. So there's usually the need for drying of the water vapor out of the product in order to produce the product you're looking for with its physical properties that are acceptable. So the first definition that we want to talk about is absolute humidity. Absolute humidity is a broad term for the measurement of water vapor. It's usually defined in terms of either dew point or frost point or parts per million, or in some cases when it's a very dry application, such as a lot of semiconductor applications, parts per billion. And again, that's generally on a volume basis, not a weight basis. So water molecule, most everybody knows, of course, the chemical formula is H2O. So there's 2 hydrogen atoms and 1 oxygen atom. Molecular weight is 18. The hydrogen atoms are bonded together with 1 oxygen atom. It's also a polar molecule. So there's a positive side and a negative side, and that becomes important. We'll get into that in more detail as we go through the presentation. The main reason for talking about the polar aspect of the molecule is because of that polarization, it will tend to adsorb and therefore, if you will, stick to most surfaces. The rougher the surface, the easier it is for the water molecule to stick to it. The smoother the surface, less likely the molecule will stick to it. Water vapor, usually talked about in terms of water vapor pressure. There's several different symbols that you'll see for water vapor pressure. I tend to use the symbol P sub W for pressure water, so water vapor pressure. And water vapor pressure is pretty simple. It's simply the pressure that the water molecules exert in a given system. So usually a system contains many different types of molecules. Sometimes it's a pure system, so it may only contain one or mostly one type of molecule, but water vapor is usually included in the mixture of gases. And if you could measure the pressure that just the water molecules exert, that is what water vapor pressure is. There's a special condition that's referred to as saturation water vapor pressure. And the symbol that I use for that is P sub S, S for saturation. So if you have an environment that is saturated, meaning the gas in the system is holding all the moisture it can hold, and you were to put one more molecule or one more drop of water into that system, it would simply fall to the bottom as a droplet of water. It would not turn into water vapor and be dissolved, if you will, into the gas. So the gas in that system is saturated with water. So if you were to measure the water vapor pressure in that special condition, that condition of being saturated, that is what saturation water vapor pressure is. And again, that will come into play as we go through the training presentation.